Okay, this is geometry 4.7, and we're going to start talking about flowchart proofs. This is an example of a flowchart proof that you'll be working on. And we're just going to go ahead and do number one. And the givens are that PQ is parallel to SR, and they're also congruent. Okay, so if I know, well, let's just go ahead and start so right here it says PQ is SR. These lines under the boxes are the reason that we can say that. And I can say that those two are parallel because it was a given. The other given is that PQ is congruent to SR. So let's not forget our triangle congruency conjectures, the four that we know. And because these two lines are parallel, I'm going to extend those so we can see them a little better. I also know that this angle is congruent to this angle, right? Let's just say that. So angle RSQ is congruent to PQS because they are alternate interior angles. So here's another. Don't I know that this side is congruent to itself? Well, I do. So now I can say that QS is congruent to SQ because it is the same line. So let's see what we have here. We have a side, we have two sides, and the angle in between them. So I can say that PQS is congruent to RSQ. And remember, the order that we say those things is very important. And the reason I can say that these two triangles are congruent is because of side, angle, side. So therefore, I'm to the point where I'm showing what I'm supposed to show, that SP is congruent to QR because corresponding parts of congruent triangles are congruent. So that's number one on 4.7. I'm going to just go ahead and present section 4.8 right now, and then we'll be done with this chapter. And I'm going to go ahead and do number 8 from your worksheets. So this is the diagram, this is the triangle that's given. And it says in an isosceles triangle, the median to the base is also the angle bisector of the vertex angle. And we're going to go ahead and prove this. Given that ABC is isosceles with AC congruent to BC and median CD. So if this is a median, I know that this is congruent to this. All right, so I'm going to show you actually the kind of proof that I prefer to do just because I think it's faster and easier to understand. You guys will decide of the three proofs that I'm showing you. The first one was a paragraph proof. The second one was a flowchart proof, and this is called a two-column proof because we're going to set up two columns. And I don't really care how you do your proofs unless it's given to you. If a flowchart is given to you, then I expect you to be able to do the flowchart. So the first thing you do is always state your givens. Okay, and if you reread through this and these, we're given that ABC is an isosceles triangle. We're given that AC is congruent to BC, and we're given that CD is a median. Okay, so as I've marked before, I added this part that AD is congruent to BD because that is the definition of a median. And I also know that angle A is congruent to angle B. And the reason I can say that is because base angles of an isosceles triangle are congruent. So now I'm ready to show that ACD, I got to keep going back to the picture, ACD is congruent to BCD because of side, angle, side. I have the two sides and the angle in between them that I've proven. So once you make this statement, the last statement is almost always, remember, we want to show that CD bisects this vertex angle. And I can say that angle ACD is congruent to BCD. I can show that these two angles are congruent because corresponding parts of congruent triangles are congruent. And then we have one last statement to say. And this statement is always whatever this is. So CD bisects angle ACB because that's the definition of an angle bisector. I'm sorry I can't get that whole thing in there. We'll work on this in class too, so don't worry about that. We'll do lots of proofs, lots of ways to do proofs when we meet together in class. And that's it for chapter 4.